Hi, my name's Jacob Brown. I'm from Newfield, New York. I'm a member of the class of 2022, and I'm a math and physics double major here at Ithaca College. I'm just here to talk about some of the really interesting learning experiences I've had during my first 2 years here at Ithaca College. Really, the main being that I've been able to do research in both math and physics, which has been absolutely amazing. Both of my projects that I've been working on were so much fun, and I'm really glad that I was able to do these at a very early time in my career. You don't get that in a lot of places. So I just wanted to show you what I've been working on these past 2 years. I'll start with physics. So for physics, what I did is during my freshman summer, the summer after my freshman year, I participated in the department's summer scholars program, which is a program where students get on-campus housing and they get to do research full-time with the professor. And that's actually paid research. And it's a really amazing sort of thing that you don't get to see very often, to get to do paid research after your first year of college. So my project focused on creating this object on the left. It's called a superconducting quantum interference device, or called a SQUID for short. And what this is it's a very sensitive magnetic field detector. It's incredibly tiny. This side is 10 millimeters and this side is 5 millimeters. And what you see right in here is blown up over here on the right. These are the squids themselves, these two things right here. And what we do is we have to carve them using lasers, and we actually blast this superconducting material onto this chip here using lasers. And then we use a chemical process to remove the remaining film and get the shape that you see over here. And it was a really fun project to work on, especially during my freshman year when I have not had this much lab experience before at all. And to be able to do something that this was quite lab intensive. Math. So for my math project, what we worked on is we examined discrete dynamical functions, which are functions where you take their output and plug that back into the function itself. More specifically, we focused on the logistic family of functions. So if you have a parabola that goes up and down like this, what you're doing is you're taking this output that, say, is right here, and then you're plugging it back into the function, and then you'll get, and let's say, a value over here. And what you're doing is, as we change that value of the parabola that maybe looks like this, and we make it steeper, what happens is over time, as you plug the values in itself more and more and more, you'll find that it either bounces between values in sort of this sense. Here you'll see that it, say, r equals 3.2, it bounces between these two values of the output. But as you change this value up here, that makes it steeper or less steep, you'll find that it begins bouncing between 4 values or 8 values, as you see here. And eventually we orbit into complete chaos where you can't predict where the function will take you over time. And this area is blown up over here, so you can really see the chaos that emerges out of the discrete dynamical function. You'll also see that eventually it sort of gets back into order. Here you can see here, and then you see these lines that sort of follow through. And that's sort of the mystery of these discrete dynamical functions and how they sort of work with these extremely precise values that you adjust the sort of steepness of that parabola. And what I find really, really cool about these images is that the professor I worked on these with, he's writing a textbook about this, about discrete dynamical function. He's using these two images in his textbook, which I think is amazing, because I was doing this during my the fall semester of my sophomore year, and I already have a image in a textbook, which I think is incredible. I couldn't even imagine that. So aside from just the research, the departments themselves are incredible. The professors really value student input, and they really value you as a person. If their door is open and you have a question, you can go ahead and go right in. They're more than happy to see you and just chat about, even if you just want to go and talk about some cool things that you discovered or looked at in, say, physics or math or anything. They're really happy to talk with you, and they really value you as a person, which I think is pretty rare in a lot of departments. You don't see that in sort of these bigger institutions where you're just a name on a piece of paper. Whereas here, the professors know you by name, they know who you are, they know what you're interested in, and they really want to see you succeed. And it really feels good to have these professors behind your back all the time. And I didn't come in as a math and physics double major. I actually only came in as a physics major. But the more classes I took in math, I really enjoyed not only the material, but the professors. And they're so great in how they present the material, but also how they treat you as a person. So that really was a big influence in how I decided to become a math and physics double major, is that the professors are really supportive of that sort of thing. And they'll make you succeed and they'll help you succeed in any way they can. So I really hope that this helped you discover more about what IC has to store, and I hope to see you around the campus.